This video is on the recursive formula for sequences. And when we write recursive formulas, we're going to write it so that the formula is based off of the terms that come before the one that we're looking for. So we're going to say the terms are based on the terms before them. Hopefully that kind of makes sense. And you've learned these before. So for arithmetic, we have a sub n equals a sub n minus 1 plus the common difference. So this is saying if I want the fifth term, and my pattern is that each term goes up by 3, then to get the fifth term, I would take the fourth term and add 3 to it. Or if I want the seventh term, and my pattern is that we go down by 2, then I would take my sixth term, subtract 2, and that would give me my seventh term. Now, since these are defined recursively, the next term is based off the one before it, that means we have to have a term to start with. So typically we'll give a sub 1. I think technically you could probably give any term you wanted. So if you want to give me the second term, I guess that's okay, but typically we do with the first term. For geometric, it would just be a sub n equals a sub n minus 1 multiplied by r. And you can put the r on the end right here, or you can do r as a coefficient. Whichever you want to do is fine by me. And then again, we need the first term. So if you write me a formula without a first term, then I'm going to make up the sequence that I want it to be, and I will guaranteed make it up wrong. So make sure you always put the first term there. So for our examples that we're going to do to remind you of what you learned last year, the instructions first are going to be find the recursive formula. So first we're going to look at the sequence 3, -5, -13, -21, etc. So if I look at this, I can see that this is an arithmetic sequence, and I can see that the pattern is it goes down by 8. So I'm going to say a sub n equals a sub n minus 1, take away 8, because that's the pattern, and then I'm going to add in there that the first term is 3. That's all we have to do. For the second one, I'm going to go ahead and give you an explicit formula. So we're basically going to convert it into the recursive formula. So in this explicit formula, I can tell based off the way that it's written that the first term should be 5, and that the pattern here is it goes down by 3 each time. And the reason is because I know that in the explicit form this is the value for a sub 1, and this is the value for d. So I'm going to go ahead and write a sub n equals a sub n minus 1, subtract 3, because that's the value for d, and then I know my first term is 5. Alright, let's do 2/3, 1, 3/2, 9/4, 27/8. So if you look at this one, this is geometric. Over here you can't see the pattern quite so easily, but over there you can see the top of the fraction is multiplying by 3 and the bottom of the fraction is multiplying by 2. So if I had 2/3 times 3 over 2, that gets me 1. 1 times 3 over 2 is 3 over 2, and then it multiplies by 3 over 2 from there. So I'm going to say my r value is 3 over 2. So a sub n equals a sub n minus 1 times 3 over 2, and I'm including my first term is 2/3. And then from an equation, so this one, I can see that the r value is -3, so it's multiplying by -3. And then we have to be careful here because sometimes in geometric sequences we'll see the exponent as n minus 1, which is where our formula came from, and then if you see the n minus 1 as the exponent, you can look in the front, now it must be your a sub 1. However, if we look at this problem, it doesn't say n minus 1 as an exponent, it just says n. which means that 5 is not the first term. So I'm going to go ahead and write everything except for the first term. But then to find my first term, I'm just going to go ahead and plug in 1 there. So 5 times negative 3 to the first power is just 5 times negative 3, which is negative 15. So be careful to watch out for that. That's a common mistake that I would see students make, is to just automatically assume that's the first term, even though it doesn't match what we've done in the past. Okay, so that's like the Math 3 version of what we have done with recursive formulas. So now we're going to move on to like what the pre-calc version could look like. So we're going to go ahead and we're going to find the first 6 terms for these recursive sequences. So on these, I wouldn't necessarily make you guys write an equation for a sequence that looks like this. But I would expect that if I gave you the formula, you could then find the other terms of the sequence. So what we're going to do here is we're saying that the formula is a sub n equals n plus a sub n minus 1. So what the n means is that's the term number that you're on, because this is defined as a sub n. So a sub 1 would have a 1 in right there, a sub 2 would have a 2 in right here, a sub 3 would have a 3 in, etc. So a sub n. So if I'm going to find the second term, then that means I'm going to do 2 plus a sub n minus 1 would be 2 minus 1, that's 1. So it would be 2 plus whatever my first term was, which in this case is 2 plus negative 5. So my second term is negative 3. My third term is going to be 3 plus, and then 3 minus 1 is 2. So it's 3 plus whatever my second term was. So that's 3 plus negative 3, and that equals 0. My fourth term is 4 plus whatever my third term was, and that's 4 plus 0 equals 4. My fifth term is 5 plus whatever my fourth term was, and again, the reason I'm getting this is because 5 for the fifth term, 5 minus 1 is 4. That's how I know that's what that is. So that would be 5 plus 4 is 9. And then my sixth term would be 6 plus the term before it was 9. I'm not showing as much work because I think we're going to be able to get the hang of it, is 15. Now, when you're writing the first 6 terms of the sequence, please don't leave it a mess like this. Please just write out the first 6 terms. So if you want to do the work in your head, you always can. I think on these it's a little bit risky. I was making a final with another teacher, and we did not show our work on this part, and we made a multiple choice final question that had no right answer because we made a little mistake in somewhere in here, and then it messed up all the answers. So just be careful to watch for that. Okay, and then one last one. So this one is a sub n equals a sub n minus 2 plus a sub n minus 1. So you might not have seen the a sub n minus 2 before. And here, since we're doing it recursively based off of 2 previous numbers, that means that for you to be able to write this sequence, I have to give you the first 2 terms. Or not even necessarily the first and the second, but I'd have to give you at least 2 terms. Right, now you'll notice when it said find the first 6 terms, I didn't tell you to find 6 terms. I told you to find the first 6, which means that you included the first one I gave you in the ones that you wrote down. You don't ignore the one I gave you, you include it. So that means if I gave you the first 2, you only have to find the third term through the 6th term. So we don't have to necessarily find everything else. So if I'm doing a sub 3, then a sub n minus 2 would be 3 minus 2. So that's 1. And 3 minus 1 is 2. So the third term is the first term plus the second term. So that's 3 plus 7 makes 10. The fourth term is going to be 4 minus 2 here, which is 2, and 4 minus 1 here, which is 3. So the second term plus the third term would be 7 plus 10, and that makes 17. The fifth term would be 5 minus 2 is 3, and 5 minus 1 is 4. So the third term and the fourth term is 10 plus 17, which is 27. And then the sixth term would just be the two terms before it. I think we've noticed that, and that is 17 plus 27. I guess I should have written 27 plus 17. You get the idea. No, I did it right. Okay, anyway, sorry. So this one would be 44. And then if I write out the six terms, I would say first I had 3, then 7, 10, 17, 27, 44 for the six terms.